Hello everybody, so today we're going to do some NumPy. I got the camera on, but first we're going to do some indexing in NumPy. Today we're just going to focus on NumPy. So hopefully you already understand like the basics from the last video. You already understand like how to create new arrays, how to make like plots in NumPy in matplotlib. And I can show you like first we'll learn in regular Python. So regular Python, we're gonna learn about lists, because if you didn't learn about lists yet, if you learn about arrays, well, we already learned about arrays, so I hope it's easier than arrays. We're just gonna be doing indexing, so creating a list in Python is easy. You can just do this. Just use these brackets, and inside you can have, this is like a numerical one. Let's just make it numerical. So 4 values, that means the length of it will be 4. The length of this list. That's how you can get the length of the list will be 4. But in Python, this is 0 indexed. So it has, this is the 0th index, 1st index, 2nd, and 3rd. So it's gonna have so that's why when you try to index it like this, you use the list, one name, and then you have these brackets again, but inside the brackets are the index name, the index number. So the index number goes in here. But we're going to put out our index number. So let's say we want to get 1. So you need to get the 0th index, because that is the 0th index. So that will give you 1. And the last one is obviously not 4. It's 3, because it starts at 0. If you try to put 4, you'll see it's going to have an error. And if you don't like know the name of the list, the number of elements in the list, you can just use the length. But you can't do it by itself. You have to do -1, because if it counts the number of terms, and there's 4 of them, 4 terms. So, but there's no 4th index. There's only 3. So that's why you got to do -1. Or you can just have -1 by itself. It'll give you the last term, and you can have -2. It'll give you the 2nd to last term. You have -3. That's the 3rd to last term, and I don't think is really necessary. So -4. Why do you need to do that? You can just put 0 instead. But it's okay. You just try it out just for learning purposes, and we can try to iterate the list, iterate through the list. It's not that hard. It's pretty easy. You just use for a variable in range, for I in range, and we can just go for the length of the list, and then we can have we can just print out the index number. So this I will be like the index number. Just think of it like as the index, and so, or it can also stand for iteration, but this is the first, the 0th index, 1st index, 2nd index, and 3rd index. So we will just give it in that order, 0, 1, 2, 3, and now you can print out the list and those elements. So you can print the list and those elements, and it will just give you this list out, but just like going down like this. There it is. And we can try to use functions like what we did last time, like f equals to lambda. Let's take an x, do x squared. So we can get like 1, 4, 36, 49, like that type of list. We want to make that. We want to transform it. So in order to do that, we have to let's say we don't want to iterate. Okay, so we don't want to iterate. We just want to do it very fast. We got to use a mapping. So it's called a mapping to the list. So we're going to map this. So this function will be mapped to the list. Each element in the list, this function will just transform each element. So it's going to be like the function and then the list. So this is a mapping, but we're going to make a new list with the mapping. Oh, all right there. So we're gonna make a new list with this mapping. That's what we're gonna do, and we'll get the new list with this transformed by the function. So there we have it. It's transformed. So this is just an example. Just name it new list. For completion, just there we go. We just got a new list. It's not too bad. This is just some function operations, but let's try to like focus now on indexing more. So we just did the basics of indexing, getting elements like this. Getting elements is not too hard. I hope it's not. It's just using that, using those brackets. But now what if we want to get like, instead of one element, we want to get 2 or 3 or 4, well, or all of them. And that's easy. You don't really need to do that. But if we want to get 2, you got to think about it. You don't want to just like you don't want to just make a new list getting like with like a list 0 and list 1. You don't want to do this. That's not worth it. It's just more work. You don't need to do that. You can just do this. You can just use, if you want to get 0 to 1, remember this. You're gonna have you're gonna start at, make this comment. You're gonna have if you have the name of the list. So the name of the list, and inside you're gonna have the first inclusive index and the exclusive index. So it's gonna be like this, inclusive to exclusive. So we're gonna have the list, and if we want to go from 0 to 1, we're gonna get 1 only, because of that. Because of 2 is the first index that is not included. So if you see, it's gonna give you only 1. But if you go 2, then you get both. So that's just how you can do it. You can even try to get like the last terms. Like the second to last term. And remember, the last term won't be actually given because of it's not included. So you have to do 4, or you can just do line list. So it will give you 6 and 7, and you can even get the middle terms now. So the middle terms as 1, 2, 3. Yeah, 1 to 3. Not -1, 1 to 3. Yeah, there you go. So this is how you do it. It's a string list now. So that's just basic numerical lists. We can transform it with functions. We can iterate through the list, and we can index. Oh yeah, also you can even modify the values. Like this, you can add like some value for it. You just update it. As long as something to do with integers. So now we're gonna try to do string lists. And now let's see first. Let's look at strings. Let's look at strings first. So what is a string? So this is a string here. Example of a string is like this. We have string equals to. This is just an example. You can have that, or you can have that. In Java, it doesn't have like. In Java, it's called like this is a string literal, but in Python we use anyone. It doesn't matter, but I'm used to this. So we can have like a string, whatever, doesn't matter, and then you can index this string. So you can index this string just like how we index the list, and we get a S as the 0th index, because this is a collection of characters. And this is one character right here. You can even define like the new string. You can define like a string that is just S plus T plus R. For example, it's gonna give you str. If you just print that out, it will give you str. See, because of it's a collection of those characters. So you can just do 0th index till. You can do the same thing with it. You can do that. I mean, not T. Why would I do that? 2. So yeah, you can do it with strings. This is like the basics knowledge about strings. So that's what we have to use for this list, for string lists. So we have an example like names, and we make like some names in here. We have some names: Joe, Alex, and whatever it is. We go have some more like let's see, James, 2 A's, 2 J's. Let's have one different one. Fred. Okay. So we have 0, 1, 2, 3, 4 indices, positions, 4 up to 4 position, and 5 total. So that means we can just do the same thing like this. You can just get Joe, and you can get like the -1. You can get Fred. You can do the same thing, but now let's try to get a specific value based on a character. So let's say we want to get, okay, so let's say we want to get only the name starting with a specific character, with starting with J, Let's say we want to only get J, a name starting with J. So how are we going to do it? We've got to use a lambda again. So we can just, let's see, new name list or whatever. It's okay, new name list. Okay, so we got to make a new list. And we got to map a function to it. Got to use a mapping, of course. And let's see what function. Let's go make a G. And we'll make it lambda. Taking in X, which is the name. X is the name. And it'll return X. It'll give you X. Because you don't want to have some like numerical transformation. Why would you have that to like a string? So you'll have you'll return that name if the first character, I mean the 0th character, that's in Python's language is 0th character, but in our language is first character. So it doesn't really matter what you say, just don't get confused too much. Like I do, 1 equals to J. If the 0th character is J, so that's going to be Joe and James, it's going to return that, it's going to give you X. Else it's going to be nothing, it will be none. Else it will be none. So you can apply this this function to the list names, and you're going to get a new name list. It will only give you Joe, and then this one where Alex will be none, Anne will be none, James will be in there, and Fred will be none. That's what should happen, unless we made a mistake. Okay, we did it. So that's how you do it. It's not too bad. Just you can even play around with it. You can have X plus plus another string. Plus is cool. See, it's just fun to play around with it. Okay, so that's just how you can based on some criteria, just using indexing for strings. We're not going to focus too much on strings that much because this is all about numerical things in machine learning. But we're gonna have to. That's why I just presented it, so we have some knowledge about this. Anyways, let's start some NumPy. Let's think. Let's see. Let's just learn first. Like, let's go and refresh our memory on NumPy. We're importing NumPy, and then we'll create an array. Let's go create a vector. NumPy.random. We're gonna use random.rand a lot in this video because this is what you're gonna have to use a lot in machine learning. You have to use you don't want to like, why are you're gonna usually start with random distribution, so that's why. Let's just make it 1 by 5. The shape will be 1 by 5. Let's print it out. So we got 1 by 5. This is a row vector. So we have this row vector, and let's try to do indexing for this array here, this vector here. So now we know that the shape of this, it's a little bit different now. We have this new indexing, So let me go write a comment. So you have the name of the vector. Let's say it's a vector, like this. And inside we have the rows, and we have the columns as well. So now if you do this, so you have V, and inside we want to specify the row. So how many rows we have here? We only have 1 row. So we define 1 row and 5 columns. So we want to see, so if we want to see the first row, remember in their language it's 0. So we're gonna have 0. So we want to only see the 0th row. So inside, basically you can think of this as a list in Python. You see, it's actually very interesting. Like, how is it possible? It's actually a list in there that's encapsulated in the array. So you can see, I can show you. So if you have X, so let's say we have X, and we're creating a new NumPy array using a list. This is actually like a property in NumPy or for vectors in programming. So you have a NumPy.array, and then we can put it in the list that we just created. And see, it's going to be now a NumPy array. See, it's a NumPy array, and you can see the shape of it. Well, before it doesn't have any dimensions. So we'll have to reshape it. It becomes like it becomes a lot of like thinking to like what are we gonna do, like changing the dimensions, changing the rows. that's we'll think about that later. So we have the rows now. So we're seeing that the row is basically going to give us like this list. See, that's the difference. This is encapsulating this list here. This is a list. Okay, so that's what we get in here, and this is an encapsulation. These brackets here, they're encapsulating and making one row. So that's why we get the list back. And now we can see we can just do what we were doing before here, where we can just find like the 0th index. We can just get this 0.867. We can get it there, and we can get the first index. We can get the second. We can get the last index as well. But if you try to go to the first dimension, there's no first dimension. It's gonna have error. So that's why you can't do it, but it's not. You just gotta think about their language now, 0th indexing, not first indexing like us. So let's see. Let's go and use what we learned before about this, because now it gets a little bit more tricky. So if we have this now, let's say we just have this, okay? What do you think this is gonna do? Before we were just thinking of it as starting at something that's inclusive, that's gonna start at, and then it's gonna go until its exclusive point. But now this is just, who knows what it's going from nothing to nothing. What is going on? But it's actually just means that it doesn't care about the rows. Whatever rows, it's going to give you all the rows. So if we see it, it's just going to give you the same array. It doesn't matter because it's giving you all the rows. And you can see the 0th index from any of the rows. It's just going to give you that. It's just going to give you that list because that's the 0th index. There's no other index. See, if you see 1, it's not going to work. Because remember that it's encapsulated inside. So if we do, we can also reverse it. We can see we don't care about the columns. It's gonna give you that list. And now what if we try to do the rows like that? I mean the columns like that. So if we define, or we can just do 0. Why am I writing vector again? V. And the columns. Say yeah, we're gonna go to the first column. So that's gonna be this one, and we're gonna go after everything after that. That's what this means. So you can also write it like that. You will go everything after that, and you can even have a -1. You'll just go in until this. To just be all of these. So now you can just borrow that idea, and you can just think of this as the list now, and now you're indexing from that list. That's why I introduced this. So now let's see a little bit more higher dimensions. I'll keep that. See some higher dimensions. Or yeah, let's see a little bit of let's see a matrix. Let's see a matrix. Okay. This is a very simple matrix, 3x3. 3x3 matrix, and we can see what it looks like. NumPy.random, I forgot that. We can see how it looks like. You already know, but now you can tell now from what you learned before that all of these are lists in here. So it's again in the encapsulation. All of these are lists. 3 lists. 3 lists now. So 3 lists with 3 total. With the length of it is 3 of these 3 lists. So that's how you can think of it. Or they go up to 2, index 2. So 0, 1, 2. Middle is 1, last is 2, beginning is 0. So remember that, and we have 2 dimensions. So now we can try to do the indexing here. It's almost the same now. So you can remember this, it doesn't care about the number of rows anymore. So remember that's the rows, and then we have the columns again. So this is going to give you everything. It's the same. But now you can find like all the rows where the column is the index 0 of every column. So it's going to give you all of these values here. Of these values, right? Oh no, it's going to give you all of this. Give you the 0th list. So I forgot to introduce that with a vector, we can also do a similar thing like this. Because vectors are very similar to matrices. But matrices just have more columns. They're usually like 5 by 4, 5 by 5. I mean there's more rows, not columns, yeah. But we can see in a vector as well. We can do the same thing. I forgot to introduce it, but you can do like rows and columns as well, like that. So let's see that first. It was my mistake. I didn't really introduce that. That's very important to understand. Okay, so we can go back to our vector. Let me come print out v, and we can do v of the first, the zeroth. Yeah, we can also do this. If you want to be more confused, we can do that. And if we can see the first column. So you can see the first column, and it's not going to give you the numerical value because it's only giving you the first column, which is this, and it's going to be encapsulated because that is the column and in the value if we put in 0. But if we don't, if we do something else, it's not going to work. So always pay attention to that. And we can even go to the 0. We can just use 0 to make it less confusing, and we can see the last. And we can see the last like that. It will just give you the numerical value. So we have regardless of the row, we're going to get this as the column. But if you put in 0, then you're looking at the list and you're indexing from the list. If you put in 0, you're indexing directly from the list. That's what you're doing with 0. You're indexing from the list. So that's why you get a numerical value. But if you don't index from the list directly, you're just whatever the amount of rows we have, we want to see the last element. So that's why it gives you the column. So that's something to think about. Now let's go back to our array. So we have our array right here, and we can use the same idea. We can have like regardless. We don't care about like the rows too much. We want to see the middle. We're gonna do 1. So it's gonna give you all of these values here as a column. See, and now this becomes now the new list to think about. And you can get the middle. You can get the middle element from there as well. And you can have the 0 now. You can use the 0, and that will be only focusing on this, or the 0th row. So you can't have like another one after that because it's going to give you a numerical value. So you're going to see this 0.835. So it gives you 0.835. So that's just playing around with it. And we can try now using functions. Let's say we want to see a value in this array, and we want to in this matrix we want to see a value that is greater than a specific threshold that we have. So let's say we have a threshold that's equal to, you can see already in here all of them are less than 1, so let's say 0.3. So we have a 0.3 threshold, and now we want to see which one is greater. So we can make and we want to only keep the one that's greater. So similar to like the string list, what we did, we want to keep the ones with a specific starting letter. And let's go create it. So x, and we'll return that x value if x is greater than threshold. Else it will not. The same thing, and we can map it again. Make a new list, and we can map h to that map the function to that array, which is a. Kind of annoying. You gotta do iterations now. Alright, so we gotta do some iterations. Let's try. It's good practice though. So let's see, for I in range, len of each list. Yeah, gotta do len of how many elements in A, so we can see A right here. But what we gotta think about what I will go through. So we have 3 by 3, so I has to go up to 9 basically. So we gotta do column. So we can't, because this is a matrix, we have to go for each row and each column. So that's why it doesn't like what we're doing right now. So we gotta do a dot let's see, print a of I, and it's gonna give you all those. Okay, that's what we wanted actually. We wanted all the lists, so we got it. Yeah. So that was my mistake. We can print a, we can just print h of a I. And no, yeah, we gotta go for each. We gotta use j now. For j in range of a dot shape. And we gotta go for the other dimension now. And in there we have to use, let's see first if we're getting things correctly. We gotta go for each element value. So it's good for indexing. We'll learn indexing from this. So I remember I is for the 0 shape. This is for the first shape. And we can just use J here. So it gives us all the values now. And now we can print, if this is, we can print, now we can print J, H of this. Okay, H of that. See, so we're checking this, so we got it. So this is how we can do it. So this is just using the iterating method. So we got all of them that are none, and we got them that are greater. If we want to see some values greater than threshold, we can just do this also. I didn't think of that. A is greater than 0.3. There we go. Oh yeah, I didn't think about that. We can also do this. This is like a very simple method to do it. How did I not think of that? That is the simple method. And you can even do like another one. So A is greater than 0.3. Or A is greater than that, or and A is less than 0.4. Probably, yeah, there is one of them. I forgot to put the multiplication sign, but there it is. So that's just another way to do it. That's the best way. What was I doing here? Just maybe just practicing, right? Anyways, we can do that with a vector as well. We can have a vector, and we can have v is greater than 0.1. Yeah, we can have the same thing. This time we're gonna make a new array. So j, and we're gonna make a numpy.random.rand. And now we're gonna have a layer introduced. So now a layer is introduced in this, and now I don't know what to call it, but really layer, and inside is now an array inside of that. So matrix is inside of the layer. So you can see the shape of it, it's gonna give you that. And now we can see what it looks like. So we have an extra encapsulation to the array. So now inside is this, inside is the list, and then makes it array, and then makes another layer in there. So it's a little bit confusing, but you can see like indexing this now. Remember, it always goes down to like first like the layer, array, columns, and all those whatever. We already went over that, but soon it becomes simple. It becomes like a list, and it's indexing a list. That's not too bad. Don't be like afraid of what we're gonna do. Okay, j of the 0th dimension. I mean, not the dimension, the 0th layer, which it only has one layer. So it's gonna give us like basically the array. It's gonna give us the array now. We can do that, and we can see the 0th row. I mean the 0th. Oh yeah, let me go and write a note on it. So if you have some array, I mean like array in a layer, whatever, we can make it some name, j, and we want to see this is a layer, and then we have now back to the rows, columns. I think it should be like that. Let me check. That's the good thing about programming. If you get confusing, you can always check. So let's see what it gives you. Okay, so when we look at the 0th layer, there's only one layer, so it's going to be 0, index 0. And we can see, we're going to look at this 0th list, which is the row, and we're going to look at the 0th term, so that's right here. So that's what it does. I'm not going to get too much into the details this time, because when we reshape things, this is going to be like a lot in the videos. We're going to be focusing on this a lot when we reshape, and then matrix multiplication with these. It happens a lot. We have like a lot of things in machine learning. It gets complicated. But this is just like an example. You can play around with it, and you can see, just remember what happens. You can get that list back, and now you can get that list. You can do like, so we're looking at the layer here. And now this becomes a list, because there's only goes up to 1. Look at it, the rows, 1, 0, and 1. So now, because of the layers in there, encapsulation, now we're looking at which list is inside. You see, it's first like, remember all the encapsulations, that's meant to like just be more tricky, but it's really just indexing like different levels. So first it's like the layers, rows, and columns. So first it becomes like extra encapsulation, then an array, and then a list. So that's all really we're going to be focusing on for this video. Right, then I'll see you next time.